Today we take a look at collaborative filtering, which is a part of recommender systems. Now you may not have heard of this term, but collaborative filtering essentially means that as nowadays we really have products where there are a huge amount of, let's say, books on Amazon or movies on Netflix or songs on Spotify. Users just can't possibly weigh all their options, and we have to give them some recommendations based on what they've already done. We have to recommend, basing it on similar people, what their preferences might be. So recommender systems is really a pervasive thing, because think of it: you're looking for a scientific article in on Google Scholar, and you got your related articles. You're looking at videos on YouTube, you got your related songs or videos. You're as already was said, going to pop up into recommendations while browsing on Amazon for books or movies on Netflix or songs on Spotify. But also when you look at, let's say, beer reviews, you would like to get a really nice, cunning beer review suggestion that you haven't thought of, or even if you're looking for classes in the university. All these go under recommender systems. Okay, now our basic problem looks like this. We have a user, his name is Toby, and he has seen some of those movies here. So out of all the movies we're looking into, and there is only a small set here because we want to really constrain our problem at first, he has seen The Snakes on a Plane, Superman Returns, Yumi and Dupree, and these are the ratings he has given to those three movies. But he hasn't still seen Lady in the Water, Just My Luck, and The Night Listener. And now the question is, which of them would we recommend him with the highest number? And our final solution is actually right here as well. We're going to tell him to look at The Night Listener, because the rating we're generating for him is going to be 3.385. So you can really see something that's really well applicable from marketing point of view. We can do this in SAP Predictive Analysis tool, and now let's get closer to the problem. Let's get closer to the problem. Here is the data table with our data here. We have 1, 2, 3, 4, 5, 6 movies. And we have actually 6 movie critics, plus 7th is Toby himself. And all the ratings that have been given to the movies are here enlisted. We can see that, for instance, Michael Phillips hasn't seen Just My Luck. Claudia Puig hasn't seen Lady in the Water. Michael Phillips hasn't seen Yumi and Dupree as well. And as we already know, Toby hasn't seen 3 movies. Plus, Jack Matthews hasn't seen Just My Luck. So there might be some empty places in our table. And naturally, since Toby has already seen 3 movies as well, we can only give him 3 recommendations in this case. In real life, however, we have really thousands of movies. We have thousands of users. So the table will be huge. The table will also be what's called sparse, which means that most of the values are actually going to be zeros. Because if you have thousands of movies, any critic will hardly ever see more than tens or perhaps 100 of them. So there will be a lot of zeros in the table, and much less information than this in this example problem. So that's why the initial data for us is actually given often in this form. We have a name of a reviewer, Lisa Rose, the product, or this time it's a movie name, Lady in the Water, and the rating. So that's how we are presented in the initial data. So then we'll have to go from this state of data, or rather the recommender systems have to do that, into this table to get going with the analysis.